Well, thanks for having me. As Oswald mentioned, this is my second year here, and two for two. And the FrontCon. I'm a Doug Sillars. I'm originally from Seattle, Washington, but for the last 2.5 of 3 years, I've been traveling around Europe with my family as a digital nomad. I'll talk about that in a second. And it's really cool because Edgar is here. Is actually going to watch my dog next month while I'm doing some traveling. So like, FrontCon family. So that's awesome. So I mentioned I'm traveling around. I'm doing freelance developer relations. So I talk to developer communities about, you know, communicating different technologies. I also am really focused on performance, how to speed up websites, how to speed up native applications. I do workshops on how to speed up apps with images. I'm going to talk about video today. I'm starting to talk about AR and VR because I think that's a really growing thing on the web. I wrote a book for O'Reilly on how to speed up Android apps. That's the PDF. I'll post the slides later, but if you want to download the PDF, have at it. And if you ever have any questions about developer relations or performance or any of the stuff I talk about, I'm the only Doug Sillars on the internet, so I'm pretty easy to find. But today we're going to talk about video. As we all know, video on the internet's taking over like mad, right? You hear stories about how Netflix is X% of the internet every night when everybody's just watching TV. And video is awesome, but if you think about what is the largest file on any web page or any app, video by far are going to be the largest files that you're ever going to deliver in terms of content these days. And that leads me to my subtitle of my talk, which is Video Killed My Data Plan. And I came up with this idea because in December I had the opportunity to go to Russia for a conference, and I have an Irish SIM, and I was like, oh, I wonder how much it's going to cost if I roam while I'm in Russia. And it turns out it's 10 euros 24 a megabyte. So when I start talking about data usage, I'm going to present everything and how many euros it would cost me if I consume this content while I was in Russia. And you always hear about edge cases, right? And you know, when we're building websites, we're building apps, we're not really worried about edge cases, but this is an edge case that could really screw over some people. Like, hey, Dad, why are we still eating rice and beans this month? And it's like, well, it was either like pay my cell bill or like we don't eat or whatever. So video can really cause a lot of harm if it's not optimized properly. So I went out to see what we're doing in terms of video on the web. And as you guys know, WebPage Test? WebPage Test, I see a few hands, yeah. It's an awesome tool to test your web pages. And HTTP Archive is a tool built on top of it. And it goes out and scans 500,000 websites every 2 months. Or twice a month, sorry. And they just changed it to 4 million websites every month. So it's a really cool resource. All of the data is up on Google BigQuery, so you can analyze all the data of what's out on the internet today. So WebPage Test looks like this. And when you actually test this, you can set your test location, so you can test anywhere in the world. You can see how fast your web page is in Asia, in the United States, in Europe. So you can see what your customers are actually seeing. You can test actual devices. So here, this is an actual Motorola G4. It's a real device in Virginia that the test is run on. You can test the speed. I think it's important to test on slower network speeds because not everybody's on blazing fast internet. And then you go and you run your test. And you guys know Webpack. Webpack? All right, so the Webpack homepage late last year had 600 302 redirects in it, which I discovered by just testing with WebPage Test. And what happened is if you ever go to the Webpack webpage at the bottom, they have a picture of every single one of their sponsors, and they've got, lo and behold, about 600 sponsors, which is awesome. But the open source library that they used to serve those images changed the way they were serving the images, which ended up adding a 302 redirect to every single image request, making there were 1,100 requests to load this page, right? It's just adding time to make the page load. Pull request, we got that fixed. It was pretty easy. But this is how I use WebPage Test to find performance issues with applications. Using this and the HTTP archive, we can find that video on home pages is growing, right? It's not a huge number. It's like 5% on desktop, 4% on mobile, but it's growing, and we can expect that we're going to see more and more video as people have faster and faster devices, faster and faster network connections. More and more people want to put video on the web. When we look at how fast web pages load, once there's video, this is speed index, and speed index is measured in milliseconds. So the median web page with video takes about 11.5 seconds to load, whereas all other sites take about 7.5 seconds to load on mobile. So we're already adding like a 4-second delay for the web page to load if we're adding video, right? So we all know that the faster a web page loads, the more people will use the website. People don't abandon it. If it takes too long, people will abandon your website. What's really interesting is that extra 4 seconds isn't to be blamed just on video, right? There's only 2.5 megabytes of video, and the websites are about from 7 to 1.2, so they're like 4.5 megabytes bigger. So this sort of makes sense as well, because when you have video on your web page, you also have a lot more CSS, a lot more images, a lot more JavaScript. It's a more interactive site, right? So when you have video, it's definitely not a plain vanilla site. And so you can see the median web page with video has double the JavaScript, triple the images, double the CSS, right? So your websites get bigger and bigger the more you use video. And so I was like, okay, so where is the video coming from? Where's it being served from? It's all in the database, so I can look that up. And I was actually shocked that 67% of all the requests are coming from Facebook, right? That's the Facebook CDN. I was like, whoa, you know, Akamai, Google Video, Cloudinary, Amazon CloudFront. Yeah, those I expected, and I expected to see Amazon, or I expected to see Facebook there too, but I didn't expect it to be 2/3 of all of the requests of video. We'll talk about that as I get later into the talk, because there's a story behind why Facebook is so high there. When we talk about, when people talk about how video is delivered, there's 3 metrics that we look at. We look at, did the video start playing, which seems really basic, but is actually really important, right? If it doesn't start playing, you failed. Did it stall? We all know when we watch video, if it stalls, you kind of stop watching and you move on to something else. And then did it look good? And if we optimize video, we can make sure it starts quickly, we can make sure it doesn't stall, and we can make sure that it looks good. So that's what we're going to talk about through the rest of the talk. And when video stops, this marketing company came up with this idea of buffer rage. When the video stops, people get angry and they get really, really frustrated. And one of my favorite studies of mobile performance is people admit to throwing their phones when stuff doesn't work. So if you get buffer rage, you might end up chucking your phone, and I wouldn't recommend doing that. But we have data on this. So let's find out what sort of data we have on video startup and video playback. And the data I'm going to present here is from Conviva. And Conviva is an analytics company. And this is from Q3 of last year. And it's like based on like 16 or 17 billion video plays. Like this is large amounts of data. But what's really interesting to me is like on the desktop, almost 4% of video fails to start playing, and 3% on mobile. Like it just doesn't play at all. And that's nuts, right? Can you imagine like if we were building web pages and they didn't load 3% of the time? It's supposed, no, this is like you press play and it doesn't start, right? So it's like, you know, we all do that on our phones, right? It's not working, you start banging. So I went through and, you know, there's some 404s, there's some 500s, that sort of stuff. You know what I think most of it is? I think it's, you know, geolocation, right? So you go and you click a link and it's like, oops. And you're like, damn it. Amazon, I have a US Amazon account, and when I'm traveling, if I fire up the video app on my phone, it's like, oh, you're traveling. Here's the stuff you can watch when you get back to America, but we don't have the rights to show it in Latvia. But here's stuff you can watch while you're here. So it saves me that click of getting the oops. Like, oh, yeah, I can watch. No, I can't. To make matters worse, this CBS webpage, when I load this here in Europe, you'll open up the dev tools. It takes 230 requests and 3.1 megabytes to tell me oops. Right? And it looks like it takes 19 seconds. It doesn't take 19 seconds. It's sending off a beacon saying, oh, no, it's not playing. No, it's not playing. No, right? It's horrible. Sort of understandable, but there are ways to work around it. But the one that really blows my mind is this. So people press play, and the video, they give up before the video starts playing. 16% on mobile, but like nearly 3/10 on desktop. They press play, they're waiting. It doesn't start, and they give up. Everything works. Like technically it works, but it's taking so long. And the reason for that is that on mobile, the average startup time is 3.5 seconds, and for some reason on desktop, it's 6 seconds for the average startup time. And that just blows my mind, right? That means we're sending down like 4K video or something, and it's just taking forever for it to start up because you have to download so much video for it to start playing. There's other research for this, right? Everyone will wait 2 seconds when you press play, and then people start to abandon at an abandonment rate of about 6% every second. For short play videos, people give up faster. So if it's a video of a cat dressed up like a shark sitting on a Roomba chasing a duck, people abandon faster because they start questioning their life choices. But if you're watching a movie, you hang out a little longer, right? You're going to hang out for an hour, 2 hours. What's another 10 seconds to get that video to start? It's not a big deal. But let's look. We look at all the websites out there. 36,000 of them on mobile have video, 55,000 on desktop. As you might imagine, pretty wide overlap, right? Most of the sites that have video on both. But what was really interesting to me is that 19% of all the videos are identical on desktop and on mobile. So that means either we're serving video that's optimized for mobile and it's going to look crappy on the desktop, or we're serving really, really high quality video that's going to take forever to load on mobile, which is probably what it is, right? We're serving desktop quality video to mobile devices, which you know is just going to add delay. And it's going to take longer to process on the phone because it might actually have to throw away pixels to put it on the screen. So last year when I was here, I talked about image optimization. This is Josephine the goat from Seattle. And I talked about ways you could optimize images to make them smaller. The same thing really goes for video, because video, you need to optimize the pixels, and then you need to optimize it over time. So I took this image of Josephine, 2.5 megabytes. I lowered the quality. Google recommends 85%. There's another way you can go even better. It's called structural similarity. There'll be references at the end. You can take a look at it. But I get it to half the size, right? So we're making the image smaller. We can do the same thing with video. We can change the format, so we can look at different video formats to make the file smaller. And then, of course, you can resize it. If I make this responsive in the correct size for a mobile device, I'm going to use fewer pixels. And now the file is 10% the original size, right? This is what we want to do for video as well. For this, I use Cloudinary, which is a cloud-based tool, and you just add parameters to the URL, and it does it all for you magically, which is kind of fun. So we look on the web at image optimization. This is megabytes of video, percentile of websites. And what we see is on mobile, we're serving less data than we are on desktop, as we should be, right? Smaller images on mobile than on desktop. I would like that number to, I'd like the mobile to pull away from the desktop a little more, right? I think we could really optimize mobile a lot better. So I did the same analysis with video. The first thing to notice is watch the y-axis change when I add video. Oh yeah, it's 10 times bigger, right? And then the other thing to notice, it may be hard to see, but we're actually serving more megabytes of video to mobile devices than we are to the desktop devices. So we're actually serving bigger files to mobile devices than we are to desktop. This sort of seems backwards. So obviously there's a lot of optimizations that we can do here while we're serving video. So video, here's Nora the goat, also in Seattle. Video obviously has frames that play back over time. There's an audio track. These are all things we can optimize. And so here's the Wikipedia version of video compression, because there's a lot of math and science, and I don't have enough time to go through all of it. But basically, the green frames at the end are the iframes. They're the full image. Just think of like a full JPEG. The P frames, the pink ones in the middle, are 50% the size. And they use math to do estimations, so you don't have to have as big an image there. And the B frames are 25% the size. And so we're doing all of these math and vectors and linear algebra to do all this compression to make sure that we can compress through both X, Y dimensions and then also through time. And so when you optimize the P frames, you start getting vectors like this. And you can build this in FFmpeg. So this is Nora the goat eating, and you can see all of the compression that's going on in the P frames. We can see it in the B frames. And then all of the vectors combined, this is all compression happening. So these are pixels that are saved and moved around in a way that makes efficient compression in the video. This, of course, as a little side note, takes me to animated GIFs, because we all love animated GIFs and we always get really excited when we think about animated GIFs. But if you actually go back to 1990, way back in history when GIF spec was written, it says the graphics interchange format is not intended as a platform for animation. It's in the spec, but we didn't pay attention to that. All right, so here's the animated GIF of Nora eating, and it's 3 times larger than the movie that I took. And the reason for that is that there is none of that compression through time that I just described from the Wikipedia article. Literally, if there's 15 frames per second, it's 15 GIFs every second. So what you should do is just make it a video. Strip out the audio channel, make it 256 colors to make it GIF-like, and now it's only 250 kilobytes. Serve videos instead of GIFs. So it's GIF the medium, not GIF the format, right? Slow looping videos is a way to do it. And so I get asked this sometimes when I present this. They're like, but what about Twitter? Like, Twitter uses GIFs. For those who can't see, it says GIF down in the corner, right? Like, Slack uses GIFs. Facebook uses GIFs. They're lying. They're not GIFs. You can actually open up in DevTools, and it's an MP4. So again, GIF the medium, not GIF the format. Because that picture of the dog, the GIF would have been like 3-4 megabytes. It's 400K. And so the way you do that is use a video tag. You have to say loop autoplay muted for it to autoplay on mobile. And that's because Chrome and Safari engineers also sit in meetings where they browse the internet when they're not supposed to. So it has to be muted for it to play, so we don't get, so it doesn't play loudly while we're in a meeting and it's not supposed to play the video. Plays in line is for Safari. This is cool. I think I mentioned this last year, but you can actually now in Safari put MP4s in the picture tag in Safari, and it'll actually play movies in the picture tag. So if you wanted to, if you put this here, the looping video would play on Safari. Chrome users would get an animated WebP, and everybody else would get the animated GIF. So that's kind of fun. Use video instead of GIFs. It's going to save you a lot of data. It's going to make your page load a lot faster. When we're going back to video, most of the videos on the internet are actually MP4s. This is again from the HTTP archive, right? It's 75% of all the videos extensions I see are MP4s. What can we do to optimize these MP4s that we're delivering on the internet? This is from Major League Baseball. This is the Boston Red Sox page. There are 2 videos. It's the same video on desktop as it is on mobile. It's a recap of a baseball game. It's 17 megabytes. It's 83 seconds long. It's 1.7 megabits per second. It's the same video on desktop as it is on mobile. So what could we do to optimize this, right? This is one of those 19 videos that are 19% of videos that are identical on mobile and desktop. Well, we could downscale the video. And here I'm using, just because it's an easy tool, there's an automatic downscaling in Cloudinary. It lowers the quality of the video. There you can't tell. It lowers the audio quality a little bit. You might not want to do this for like a music video or anything like that, but for, announcing a baseball game, no one's going to notice 22K audio. I saved 22%. And then I could actually encode a smaller version for mobile devices, maybe 640 by 360, and it's 62% smaller. 2 different versions, it will be delivered a lot faster to your different users. Another thing I mentioned earlier that some websites are delivering more video to mobile than they are to desktop. And here's an example. This web page is delivering 260K of video on the desktop and delivering 500K on mobile. So what's going on here? What on earth are they doing? Well, it turns out that the desktop device that's being tested is not Retina, and the mobile device is Retina. So they're delivering the 2x WebM videos to mobile users. We can see that in the HTML, right? There's a different class. If it's Retina, serve this video. If it's default, serve that. The problem with this is their CSS. They hide it for small screens. So they download double the video, and it doesn't show up on your screen because the CSS hides it. So don't download more video for mobile, and if it's not going to show up on the screen, don't download it at all, right? Sort of common sense, but don't do that. Another thing you can do is when you build a video tag, one of the parameters you can use is preload equals auto. And when you say preload equals auto, that tells the browser, download the video no matter what. But browsers are smart. They always download video last because video files are really, really big. So this is a web page that I went to. And you know, when you go to a web page and you're like, oh, there's a video there, but you know, I'm on my mobile phone. I don't want to watch it because I don't want to download all that video. Yeah, these guys took care of that for you and decided that that 23 megabytes of video should be downloaded no matter what. That's not great for us as an end user. That's 230 euros, right, if I go to Russia, just because I hit this web page. But it also costs the company money, right? This is server costs. This is bandwidth costs. Like, this is not an inexpensive thing. So I think preload equals auto is great if you're sure people are going to watch it. Like, if you got a 90% probability that they're going to watch it, download the video. By all means, do it. But if they're not going to watch it, don't do that. This isn't the worst you can do. If you're aware, well, here's another example. I actually found this one today. I went to the McLaren website, and they have a preload equals auto. And I actually have the page open because it's kind of cool. So let's go to that, right? See any video? Anyone? You want to see what the video is? I downloaded it. Maybe it'll play. I thought it was downloaded. Oh, yeah. Well, I'll connect to the Wi-Fi. We've got time. Or is it the FrontCon phone? Will that one be faster? I'll give it a second. Anyway, the video has nothing to do with cars. And it doesn't even really appear on the website anywhere. Just to make matters worse. All right. I'm logged in. Done. Play. Refresh the page. There we go. That's 7 megabytes, desktop and mobile. Preload equals auto, but it's not on the web page. So when you use preload equals auto, that's great. But if you take it off of the page, like you stop displaying it, you're still downloading it to every single one of your users. Anyway. And you can see that in the dev tools. It's 7.4 megabytes. It took 5 seconds, right? I mean, that's just ridiculous. Don't do that. But you can actually do worse than this. And you can actually use links and add the relative preload. And when you say that, you're saying, this is the most important thing on the web page. Load this first ahead of everything else. And so this web page is actually loading the video, which is this green line right here, ahead of the JavaScript, right? So now you're limiting how you download the CSS, the images, the JavaScript, because you're downloading a video that you just deemed more important than all of the other content on the web page, which is, of course, going to delay it showing up on the screen. This web page actually hides that on mobile, so they're doing one thing. They're not showing this video on mobile, which is great. So back to preload. Preload equals metadata is the default in Chrome and on Safari. And what that does is it downloads the first 3% of the video. And so you can see that here, this green line right here. I kind of call it the mobile middle finger because it ends up downloading a lot of data on mobile. In this case, when we look at the number of requests, there's one video request. That one video request results in 2.7 megabytes, and I don't know, what is that? That's over a third of the video of the load. Maybe there's 42% of the page is this video file. The video's 1080p, it's 150 seconds long, it's 97 megabytes. So if you download the first 3%, that's like 2.7 megabytes. But, you know, this may be a really important video for the web page, so let's see where it is. There's the first 8 screens of the web page. There's the next 8 screens of the web page. Yeah. How many people scroll that far on their mobile phone to find a video? Nobody. If you have a video that far down, you should set it to preload equals none and save yourself those 3 megabytes of download. No one's ever going to see that video. Take care of your customers' data plans. Like, 27 euros, that's pizza, right? Right, that's a good meal out. So when you're doing video preload, be really careful. Don't use auto unless you know people are going to watch it. Use metadata if you're pretty sure they're going to watch it. Now, another real popular thing that's happening in video today is the background video, right? So this is a web page, and don't you want to take your kids to play at this place now? Because there's studies out there that show that background videos increase engagement by 80%. That's a marketing company that wants to sell you background videos. Take that into account. But I found this web page, and I was looking at the background video. Now, most people, when they have a background video, it's called background.mp4. This one was called Steven. I'm like, what's going on with Steven? So the video is 5.3 megabytes. That's not outrageous. But it had an audio track, right, that you never hear. And it's Steven. You should take your kids here because it's a lot of fun. It's 5% of the file. Just stripping out that audio track makes the file smaller. And no one ever hears it, so if there's no audio, just remove it. It's pretty easy to do. Loading it up on mobile. Yep, you see the green lines. It's downloading on mobile, but again, the CSS hides it. So you get a background image. They actually, so don't download it if it's not going to show up. This web page actually has a fallback image that's 900K that they hide in the CSS, right? So now you're at like a 5 megabyte image, a 5 megabyte video, almost a megabyte of images that they hide, and you don't see any of it. Sometimes a little testing goes a long way. All right, one more background video example. This web page, you might see it if you hang out at the top of the page for a really, really long time, but let's just look at the video. The first thing we learn is Bob Ross, also a photographer. The video is 33 megabytes, 27 seconds. It's 2,500 by 1,200. And it's 10 megabits per second. And I sort of get the feeling that someone said, we need this video on our web page. And they're like, here's the MP4. And the guy's like, okay, video, source equals, paste, yes, right? They didn't look at this because this video is huge, 33 megabytes. No one's ever going to wait to see that at the top of the page. So you should really resize your video to a reasonable size for both desktop and for mobile. As a pro tip, if you name the file 720p in the file name, that doesn't re-encode the video to 720p video. But you can go and re-encode it, and if you make it a 720p video, it's 4.3 megabytes. We're reasonable now. That's not bad. So, think about that. That's probably my phone. I probably put it next to the microphone. There we go. We'll stop that. So resize the video so it's a reasonable size for a mobile or for desktop. It downloads on mobile as well. In this case, Chrome gave up after 17 megabytes, so 170 euros. So I never get to see the video, but I get to pay 170 euros when I'm roaming. And I've kind of been harping on this about how video isn't cheap, and it isn't. Any Garth Brooks fans in the audience? I know he's like American country music. Nobody. All right. No, but we can make fun of his website, right? Yeah. All right. All right, here's his website. This is a screenshot from a couple months ago. And there's a video playing here. It's him singing, right? That's awesome. And, my laptop, you can see I've got like a video speeder upper thing in there that I use when I'm watching YouTube talk so I can watch it faster. If you look really carefully, there's another one in the above the hamburger. And that's because there's a background video playing behind this video that you can't see. So you can see the big video is 51 megabytes. The background video is 7 megabytes. There's a GIF saying it's the pre-order GIF. He's got a new album coming out. The GIF is 6.2 megabytes. But what I want to point out here is they're all being served out of S3 without a CDN. So they're coming out of the Amazon S3 environment. And Amazon S3 charges you 9 cents a gigabyte for the first 10 terabytes. Well, this web page is downloading 65 megabytes of data from S3 every single time the page loads, which is half a penny in S3 costs every single time the page loads. So in addition to, costing me money when I'm in Russia to watch the, 500 euros to watch that video, it's costing the company that built the website a fairly significant amount of money if a lot of people hit that web page, because it can, if you don't optimize the video, there's server costs that you have to pay. Throw in that there's a bug in Chrome right now where large videos aren't cached when they loop. So if you're on that page and you hang out for a long time, it just keeps downloading the video. And so 20 minutes of sitting on that web page, I downloaded that video 5 times. That's 2.5 cents, right? You're not going to make anyone go broke by doing this, but there's a cost to all of this. We should think about that. So far, we should be careful about, retina video. If the video is going to be hidden, don't download it. I see this a lot. Avoid the preload equals auto. Strip out the audio track. Don't duplicate traffic. Big files are going to cost big money for both you and for your customers. So let's talk about streaming a little bit, because I think streaming is a great way to save a lot of data for all sides of the option. And so HLS streaming uses TS files for the video files. And so what happens is you build a bunch of different bitrate videos, and there's a manifest file. That manifest file lists all the different bit rates, sends it down to the device. The device picks a stream, starts downloading the video segments, and you fill up the buffer, and then the video plays. As the video starts playing, the player starts analyzing the way things are downloading and can optimize the bitrate. It can make a faster bitrate or a lower bitrate, depending on how fast your network speed is. So let's see how that actually works in action. This is a TS or a manifest file from a TED Talk. And so you end up with video tracks. These are video tracks for when it's in an iframe. And then there's one audio track, and then there's like 30 different subtitles in different languages. So TED Talks, I guess you can see subtitles in a lot of different languages, which is really neat from like an accessibility point of view. But let's just look at the video tracks. And so what we see is there's 2 lines for each video track. The first line lists the bandwidth, the codec, the resolution, and then there's a link to where all the files are. And so what happens when you start watching a HLS stream is the player always picks the first stream to start, because it has to start somewhere. It picks the first stream on the list. We can see which ones are identical because we're looking for the TS files that are identical on desktop and mobile. What we see, if the player picks too high a stream, and we see this in both the data and in just regular testing, it starts downloading these giant segments, but the buffer takes a long time to fill, right? It's trying to download 10 megabit per second video, and it's not playing. And we all know that if it's not playing, people are going to abandon. So the player tries to very quickly switch to a different bit rate, and then the video starts playing. I think that's what's happening here. I have a wedge. All right. I think that's what's happening here. If you start with too high a bit rate, you're adding an extra step of trying to download this big file. It's not working, and then you go to a low-quality video, and you're adding to your startup time. And we all know if we add to our startup time, people are going to abandon. So we want to optimize our startup time. The best way to do that is to always start with the lowest quality video. Lowest quality video is also the smallest video, so it's going to download the fastest. And then as the player figures out what the speed is, you get to a nice bit rate and it looks good. And we've seen this when we watch videos where it's all pixelated at the very beginning and then it looks really sharp. If you start at the highest bit rate, it doesn't play, and we wait. The player switches, it starts playing, and then, but we added that extra step of trying to download a big file, costing everybody money, and the video not actually playing. There's a third way that this happens, and this is what Amazon does, and they start at a middle bit rate. It's sort of the Goldilocks approach. It takes a couple seconds longer for it to start, but it looks sharp from the very beginning. And if you think about it, Amazon TV shows are all TV shows where people are going to sit for 20 minutes, 30 minutes, long play videos. They'll wait longer. and it's sharp from the very beginning. If you ever watch an Amazon original, it doesn't start on a black screen. It starts on something full color because it's already at a sharp picture. They know it's going to look good from the very beginning. And we can actually look to see what that looks like. The lowest quality video starts the fastest. When you start with the lowest quality video, it starts playing faster than when you start with the highest quality video. And then the Amazon one is sort of somewhere in the middle. So when you have a manifest file, you can do all sorts of fun things. You can split up the video and audio tracks. So if you have different audio tracks for different languages, you can do different languages on the fly without changing the video track, which is really cool. So here you can see video is in green, teal, and gray is the audio track, which is kind of fun. So here I am watching a TED Talk. I'm testing it with WebPage Test. I'm trying to figure out what's going on, how this all works. And it starts with that 1.4 megabit per second bit rate on the left. And what happens is it immediately drops to the lowest bit rate, and it never recovers. Like, it just looks fuzzy for the entire time I'm watching the video. Like, what's going on? Like, I know when you're TED Talks, it's mostly about listening to what they're talking about, but it's also nice to have a nice picture while you're looking at it. So why is it not recovering? You know, I've got this much bit rate. I should be able to do any one of the first 5, and it's not giving me any of those. So something weird's going on. So I looked at the bandwidth, and the bit rate for that first stream is 1.4 megabits per second. But if you actually look at the file, they're serving 600 kilobit per second video. So why are they doing that? They're doing that because the buffer fills up twice as fast. Right? The player's thinking it's coming in at 1.4 megabits per second, but it's coming in at 600. The buffer's filling up twice as fast. It will never stall. That's great, but we're sacrificing quality. So I went to the other extreme. I said, it may stall a little bit more, but what if I set the bandwidth to what the bit rate is? Right? It may stall a little bit more. Understood. But let's see what happens when I do that. The first thing that happens is, again, the y-axis is going to change. Right, because I changed the bit rates. Now when I test, it drops to the lowest bit rate initially, and then quickly recovers to the original bit rate. You may see the names here. The thousands is the intro to TED Talks. Like when you watch a TED Talk, it has the TED Talk sound. That's the intro, and then that's the actual video of the important person talking. But you can see that for some reason on the intro, it's dropping to that low bit rate. And I wanted to figure out why it was doing that. So if we look at the file that lists all of the different segments, each segment is a couple seconds long. The first segment is 5 seconds long, 5.0417. The second segment is 6.8 seconds, and the last one is 0.12 seconds. And you can see how many bytes are in each one. The first one's 970K. The second one is, 100 kilobytes. And then this one is like just a couple K, 20K? I don't know. Trying to do math on the fly. But if you think about it, 5 seconds for 900K, 7 seconds for 100K, like the math isn't adding up here, right? 7 seconds should be a bigger file than the other one. So the problem is here is the way the file's written, the player's trying to download it and it isn't working right. And so the player just goes to the lowest bit rate. This isn't working for some reason. We're going to go to the lowest quality bit rate to make it work. So I played around with these numbers to see if I could make it work properly. I couldn't get it to work right. I said, to hell with it. We're going to just download the whole file, the whole intro in one file. All 12 seconds, all at once, and see what happens. And lo and behold, when I do that, it stays at that really good bit rate. And it actually goes to a higher quality bit rate. So I've actually improved the streaming quality of the video. Granted, I've taken it to an extreme where it may stall more often, but I'm sure we can find a spot in the middle where we can find something in between that's a good balance. So I've got a minute and a half left, and when it comes to streaming, you can really make some big mistakes. And one of the biggest mistakes I've seen, I call the Spengler. And there's no audio, but in this scene in Ghostbusters, this is where he warns everybody to never cross the streams. Because if you cross the streams, it causes world destruction and whatever. Total protonic something or other. Anyway, this is a website that's downloading 2 TED Talks at once. So they're competing for the same bandwidth. So instead of getting one video at high quality and one not at all, they're competing and you're lowering the quality of both of them. And so you're downloading 2 videos at lower quality. If you're downloading multiple streams, you're just going to lower the quality of those videos. So you should really only download one at a time. So this was an example of that website. My favorite website for this is I found a web page that downloads 24 simultaneous streams on mobile. I blew through 245 megabytes of data in less than 4 minutes trying to get this page to load. I had to go on Wi-Fi, and I had to test this at 2 in the morning because it wasn't that my Wi-Fi wasn't fast. I'd wait for everybody in the neighborhood to go to sleep to try to get this page to load. It's crazy. All right, but we're coming to the end. A lot of people ask me about third parties. As soon as you add YouTube or Vimeo, you're going to add 700 kilobytes of JavaScript, all these other things. So you can use them, but they have some issues as well. And I'm going to run out of time for my Facebook thing, but we can talk about why Facebook screwed up and why there's so many Facebook requests on the internet if you guys want to chat afterwards. In summary, video files are big. Respect your users' data plans. Thank you very much for listening. I appreciate it. Thank you so much.